We are going to talk about continuous and discrete functions. So those are two types of functions. We have discrete functions. So let's look at this graph. What do you notice about the graph? It's going up, yeah. There are x's, which those are just your coordinates. And the coordinates are not connected. So it says x is number of innings, y is number of runs. So can you have part of a run? Or you have to get all the way to home in order to make a run. You have to get all the way there. So you can only have whole number answers. Like, not answers, I guess, whole number of runs. You can have 2 runs, you can have 3 runs, but if at the end of the inning somebody is on third base, does that count toward anything? No. So we just have whole number runs. You can't have a point that is right here at 2 innings, 1.5 runs. Can't happen. So this is called a discrete function. A discrete unit is indivisible. That is really hard to see. So I'm going to change my font color to white and make it bigger. Can y'all see that now? A discrete unit is indivisible. Where have you heard that before, the word indivisible? We say it every day. The pledge. I pledge allegiance to the flag, United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. So indivisible means what within the pledge? What does that mean? Huh? You can't divide it, yeah. The nation is going to be one. That's what it means. So indivisible with a discrete unit means it can't be divided. So what does this mean? I'm going to make my font a little bigger, and I'm also going to change my text color. Y'all see where I'm changing my text color? And change it to white because black I could not see. What does this mean? The unit cannot be divided. We're saying the country cannot be divided. If it is divided, then the result, it will not exist. We blank things that are discrete. We are going to count. Oh, I cannot see that again. So I'm going to make it bigger, make the color white. We count things that are discrete, just like we would count the inning, the number of runs. So at 1 inning, we have 1 run. 2 innings, 2 runs. 3 innings, 3 runs. So we are counting those. We can't count half a run. A collection of discrete units will have only certain parts. Change it again. So whenever I say have only certain parts, that means you're dividing. You can only divide whenever it's equal to a whole. So an example would be 10. I'm going to change my font so y'all can see it as I'm writing it. 10 people can only be divided into certain parts. So let's talk about what those certain parts would be. If I have 10 people, I'm dividing them into groups. Then I can only divide them into halves. If I do halves, how many would be in each group? 5. Okay. Can I do thirds?
No.
Can I do 3 groups? Evenly? No. So there are no thirds. What about fourths? No, because that'd be 2.5. I can't do half a person. What about 5? Fifths? If I divide it into 5 groups, how many people would be in each group? 2. Is that? And what about tenths? Yeah, because there'd be 1 in each group. So whenever we say a collection of discrete units will have only certain parts, that means dividing it by those parts, as in groupings. So remember, with discrete, we're counting and we can't have parts of the whole. It's indivisible. Okay, let's look at the next one. So we have discrete and now we have continuous. What does continuous mean? Just keeps going, yeah. So time and distance. So whenever you go on a road trip, what happens as time goes by?
You get closer to your destination.
Get closer to your destination, yeah. Can you go, let's say you're going a certain distance, can you go 4.5 miles? Can you go 2.25 miles? Can you go 1,135.5 miles? Yeah. So we can have parts there. So continuous whole means, let's change this font, make it a little bigger. Means that we go from one point to another without break. So as we were traveling over the weekend, we could have stopped anywhere along our route to go to the restroom. But we chose our favorite place, which is Buc-ee's. But we could have stopped anywhere. But we continuously drove from home to our destination. Consider the distance from A to B. So think about going from point A to point B. There's nothing to count. We can't count, like we can count miles, we can count centimeters, we can count inches, but there's nothing to count as we go. There are no points along the way, right? We can't count the number of points. How many points are along this line? But couldn't I put, let's go ahead and add some points. Let's put in a shape. Do a little circle, change the color to red. Did y'all see how I made that? I went up to circles. I made a little circle and then I changed it to red. How many points can I put on this line? What? Yeah, infinity. Absolutely. As we go from A to B, the line continues without a break. And then let's add another little text box. There are an infinite number of points from A to B. And I'm going to move it up so y'all can see it. Put that over here. There are an infinite number of points from A to B. So if you can find an infinite number of points between two of distinct points, then that means that this function would be continuous. Since the length from A to B is continuous, we could take any part we please. So we could do, I'm going to change my color. We could find half the distance. We could do a third of the distance. We could do a fourth. We could do a fifth. And so on, dot, dot, dot. We can take any part along this line. Because we could get a decimal and that'd be okay. Therefore, we say that continuous functions are for measuring things. It's like this example was measuring the distance. But with discrete, it's about counting things, where you can't have parts of a thing. Like people, counting calculators. Measuring things would be measuring the distance between me and you. Or measuring the time it'll take to run a mile. Okay, let's go to the next slide. Oh, these are hard to see. I can zoom in. Can y'all zoom in so you can see a little better? Okay, Mario has an iTunes gift card worth $20. He uses the formula y equals 0.99x to determine y, the total cost for x number of songs. What is the domain of the situation? Identify the variables. So domain is your x value. So the domain, let's talk about the variables. What are the variables? What does x represent in this equation? Oh, it tells us right here. Number of songs. So that's where we're at. I'm going to do the little hashtag, number of songs. Okay, and then what does y represent? Cost. Is this going to be discrete or continuous? So discrete means we're counting things. Continuous means we're measuring things. Discrete? Why discrete? So what are the options for the songs? 99 cents per song, right? So we're counting how many songs. Can you buy half a song? No, normally they give you like a sample for free, but you can't buy half a song. So Discrete songs are sold as whole units, or songs are indivisible. I like songs are sold as whole units. Okay. Step 3, create a representation to help, graph or table. So we're going to do a table. What does X represent? Let's write that out here. Yeah. Number of songs. What does Y represent? Cost. Okay. So we'll start out with 0. If I have 0 songs, how much am I going to pay? $0. If I have 1 song, how much am I going to pay? No, how much were they? They're actually 99 cents. 99 cents. What about 2 songs? We need to multiply, right? 2 times 99 cents. Well, 99 cents is almost $1, right? So 2 of them would be $2, but subtract 2 pennies. $1.98. Mm-hmm. What about 3? Yeah. Okay, 4. Yeah, $3.96. Okay, so our number of songs is a discrete function. 0 to whatever. However many songs you want to buy. But what was the stipulation there? Wasn't there like a limit? The $20 gift card was our limit. So how many total songs could they buy? Could Mario buy? What would we need to do? 20. Why are we dividing? Because what? Yeah. 20 divided by 99 cents. And what does that equal? Go ahead and divide it. $20.20. Repeating. Okay, so what can we actually? How many songs can we actually get though? 20. Okay. We Mario. I can't spell. Can buy up to 20 songs. So that's the domain. He can buy up to 20 songs. Okay, we have one more example similar to this, and then we're just deciding discrete or continuous. Is everybody able to get this in? Example 3, which it's really example 2. Sandy is measuring the height in inches of her roses over time. She discovers the formula 5 plus 0.25x, where x represents the number of days if she measures between 4 and 8 days, what is the range for the situation? Identify the variables. So X, what does X represent? It tells us in here.
Oh, number of days.
Yeah, so number of days. And then what does Y represent? Let's reread it. It says, Sandy is measuring the height in inches of her roses over time. So X is number of days. So what is the other variable?
Height.
Height. Yeah. Height of roses. Oh, I can make that like that. There we go. Okay, is this going to be continuous or discrete? Okay, so measuring between 4 and 8 days.
Oh, wait, no.
So could she measure at noon on day 4 and that'd be at like 4.5 days?
Yes. It should be.
And what is she measuring?
The height.
The height. Can the height be decimals? Is the height continuing or does the height stop?
No, it's continuous.
It's continuous. So since she is measuring, remember continuous is used for measurement or measuring things. So she is measuring the height over time. Continuous is for when you measure.
Can I go there and my notebook?
Yes. All right, so it says create a representation to help a graph or a table. It'd probably be more helpful to do a graph, but I don't have the graph. I don't have a graph on here, do I? No, I don't. So let's delete this table. And we actually need a graph. So let's go to Insert, Image, search the web. Quadrant 1 graph. Let's see if that'll work. Did y'all see the one that I got? I put quadrant 1 graph. Now pull it over here. And I just want quadrant 1. So do y'all know how to crop it? Yeah, we'll crop it so that you can still see the numbers, but only quadrant 1 is needed. I'm going to take off that where it says X and Y axis. We know. There we go. All right, so there's my quadrant 1 graph. How's our graph going to look? Let's see. Here's our function, 5 plus 0.25x. Where is it going to start? at 0 days, but we're talking about 4 days, right? At 4. So if we do 5 plus 0.25 times 4, we actually get 1 plus 6, so that'd be right here. So our point is going to go something like that. No, it'd be right here. No, it's going to go through 5. There we go. It's harder than you think to do this, huh? Okay, there we go. That's what our graph will look like. It'll be continuous. It's at 0, 5, so that's one of the points for the line. And then the other one is at 4, 6. Because it's going up by 0.25 each day. And it's going to keep on going. So it's a continuous line. So a graph actually helps make a better representation whenever you're talking about a continuous function. What is the question being asked? We're going to skip this one. Did it sound like I said pew? Sounded funny. All right. The last slide for today is this one. Determine whether each relationship represents a graph that would be discrete or continuous. We're going to use these little circles to decide. So remember, with discrete, we're counting things that are only whole. With continuous, we are measuring things. So let's look at this amount of cookies in each bag. Discrete, yeah. Okay, go ahead and answer these, and then we'll come back together and see how you did. Okay, so let's see. The height of a giraffe as it grows. What do y'all think? Number of students in each class. Discrete. Distance traveled over a period of time. Continuous. Distance, it's measurement. Amount of kittens in each litter. Discrete. Weight of gallons of water. It's continuous. The weight is measuring things. You're not counting. You're counting kittens. You're counting students. You're counting cookies. You're measuring the height. You are measuring the distance. You are measuring the weight. All right, and I'm going to give you your assignments.